Now, Farshad, he's my hero out of our Vancouver chapter. I'm going to let him introduce himself, but it's people like him that make events like this happen. So make sure you give him a nice round of applause to get going.
Thank you, Dana. Thanks, everyone. Hi, my name is Farshad Abasi. I hail from Vancouver, Canada, not the one that's a few minutes up from here, the one that's about 6 hours up from here. I took the train. It's a beautiful train ride. I highly recommend that you check it out. We're going to talk about securing modern API microservices-based applications today. This is really design focused. As Adam was mentioning, you got to think of secure by building things by design and not being an afterthought. It's great, and you should test your application 100%, but you should also give a lot of thought in terms of how you're actually designing it before things are finished and all said and done. What I'm going to talk about is the culmination of I guess I spent about 4 or 5 years at HSBC Global Bank designing secure APIs for them in architectures, and this is sort of a summary of a lot of the things that I learned during those years, and going through the big digital transformation, taking all the monoliths and making them into microservices. So I hope that there are some takeaways for you. So just a quick bit about myself. I have been building software and helping people secure it for about 27 years. Half of that has been actually building software, and the other half has been helping people not repeat the mistakes that I made. Because when I built software, there wasn't anyone in the 90s teaching me how to do the stuff, and things that I made got hacked. One of the first projects I worked on was a e-commerce platform selling stuff for a large retail company in Canada, and we got breached. 80,000 credit cards were breached, and I got a call at 6 in the morning. They were like, hey, wake up, go to our website, and when you go to the home page, you'll see everyone's credit card numbers and home addresses and everything else, because what they've done is they've dumped our SQL database and renamed it index.html, as you can imagine, what that looks like. So learned a lot of hard lessons, but there was no one to teach me anything, and after a few years of building things, I decided to switch over and help people learn how to build secure software. So currently I have a software security company called Forward Security, but before that I was the principal architect for HSBC and a number of other companies where I built software and helped secure that stuff. I've been teaching security for about 21 years at a university in Vancouver. An OWASP chapter lead with Dana and a number of other folks that are here from the OWASP Vancouver chapter, Jeevan and everybody else. And also I'm one of the people that helped make BSides Vancouver happen. So come to Vancouver, it's a beautiful place. We're probably going to do this there next year. And I also love music and food. I'm a record collector, so we can talk about that if you are into that type of stuff. So as I mentioned, this presentation is going to help you get an overview of the subject matter, but really from a design perspective. So how can you design secure APIs and secure microservices, right? Companies are going through digital transformation, they're taking their monoliths, they're breaking them up. How do you do that security? Because we all know how to build monoliths for some of us, but so what we're going to talk about is what are APIs, what are services and microservices, the API gateway, and how that's really helpful. A lot of people don't even know what it is or why they should use it. The importance of user-level security trust and end-to-end context across the journey of your application, why you need authorization when you're building these APIs and microservices, and what are the different ways of doing it. What is authentication? What authentication authorization protocols can you use? And how, if you're building these APIs, how do you invoke them security by external applications and services? And then other security issues related to APIs, microservices that you should care about, and then we'll leave you with takeaway considerations. So APIs, right? It's interesting because I've been a software developer for a long time, and APIs were one of the first things I learned about. But today, when you talk about APIs, people right away they think of web APIs, right? But that's not the only kind of API that there is. So let's just talk about what APIs are, right? So generally, they're a set of methods. It helps you do abstraction. It really helps you create abstraction layers so that people can focus on what they're building and then expose their API to the other layers at the top, and that can be consumed by the other folks that are building the rest of the system. And there are tightly coupled APIs and loosely coupled APIs, but today when someone says API, they're talking about loosely coupled web APIs, right? But make no mistake that there are all kinds of APIs. And so basically used by software components to communicate. As I said, it's been around for a long time, and basically you've got an API consumer and you've got an API producer, and it's really that simple. Now it could be loosely coupled or tightly coupled, depending on the application. Many modern applications are web-based these days, And these web applications typically use REST APIs, and they're RESTful and they follow the resource-oriented architecture. And they're used to communicate externally and internally. So here you can see that there's a monolith, it's got a REST API, there's a desktop client, a mobile client, and then this monolith has got a few different functions within it. It's got the authentication authorization layer, and at the bottom it talks to other applications, and it's got a database down there that it talks to as well, all different kinds of APIs. So what about microservices, right? It's a term that probably a lot of you have heard about in the last 5 or 6 years. It's been a bit of a buzzword. I know I got introduced to it back in 2014, 2015 as HSBC was going through their big digital transformation and making everything into microservices. So they are a software development technique, right? And what it does is a variant of service-oriented architecture. So you can further break things down into individual functions. They don't have to be hosted inside a microservice. It usually is when people design microservices. They put them in containers. But it doesn't have to be like that. You could have microservices that all live within a monolith, but they're designed to be separable. That's an important thing to know. So just because they're not separated today, that doesn't not make them a microservice. So I don't know who saw the Utah monolith. This thing sat there in Utah for about 4 years, from 2016 to 2020. But monolithic applications are they have tightly coupled functions. They don't really scale very well, right? All the functions live together. So if something is being used more, that's going to consume all the resources that would be available to the other functions of the application. They're often large and complex. And they slow down development. So you've got a whole bunch of people working on different functions. If everyone hasn't checked in their code and you can't build it all, then it holds back the development lifecycle, slows things down, and issues from one function can impact the others, and it's difficult to rewrite. So this shows sort of the progression. Over there we had our monolith where everything lived together in one, and then we broke it into service-oriented architecture. In fact, when I joined HSBC in 2008, we were going through that first transformation where we were taking all of our monoliths and try to break them into services. I think IBM in the 2000s did an analysis across their entire organization, and they realized that they had hundreds of different applications, but in reality, there were only about 40 services that were repeated across these different applications. So they were one of the first companies to go forward with this whole service-oriented architecture, and then we were trying to do that at the bank as well, looking at across all of the different applications we have and see what are the common services, and let's just build these services that can be then used by made available by an enterprise service bus to the upper layer, and then people can build applications and combine these different services. But in a sense, these services were still a bit too big, and you could further break them down. So that's where microservices come in, and you can see, for example, our order service can be broken into functions, the order history and order details, and each of them could live in their own container with their own data model. And this really helps with scalability and performance. So for example, if your order history function is being used a lot, well, that's fine. You can scale that particular container, you just stand up more of it, right? And then maybe the order details is not used as much. Well, maybe you're running only one instance of that. Whereas with the monolith, if the order history was being hit a lot, then the entire order service would slow down and it would impact its performance. So, this has been a direction, and it doesn't make sense for everyone to do this, right? It doesn't mean that monoliths are bad. There are use cases where you should do that. So it just really, it's really depending on the use case of the organization. So microservices typically are hosted inside containers, but like I said, they don't have to be. They're light, and there's very little overhead, right? Like when you put things in a container, you don't have to boot up a kernel. The containers are sharing the kernel with all the other containers, so it's already ready to go. They boot up really quickly, they're light, and they're typically exposed via APIs. It doesn't have to be like that, but you can either do them directly or via an API gateway. Highly recommend putting an API gateway in front of your microservices architecture. And they typically use lightweight protocols using HTTP and JSON, which was not the case with service-oriented, right? We used SOAP and XML and all this extra stuff that was really heavy, and it wasn't really so good for internet-facing applications, right? SOAP and XML and all that kind of stuff. Service-oriented architecture was great for enterprises. You had fast networks internally, and it was a bit of a different world. But when things started to be open up externally, then you needed sort of lighter protocols. And as I mentioned, not all of these microservices need to be exposed internally. You might have microservices that just call each other internally or process a particular function without an external API. And the key thing is, though, whether you put them in containers or not, you got to design them so that they're independent, and each one has its own model. And this allows for decoupling it from other things, and it's well suited for Agile or CI/CD, right? So you can then have a small team building that particular microservice, a team of 5 or 10, and really being able to deploy this as often as they want without hindering the rest of the people that are building other functions of the system, whereas with the monolith, they would all be a large, big dependent pool of stuff. But it brings up a new set of challenges. So there's complexities of distributed systems, there's problems with maintenance of data consistency is one of my pet peeves, right? You've noticed this with some sites that have this architecture. Like I've gone on LinkedIn and I've updated some stuff in one section, and then you go somewhere else and it hasn't been updated yet, right? Because eventual consistency hasn't been reached. So you get some new interesting problems. There's a gentleman by the name of Chris Richardson. He's got the microservices book and all that stuff. Highly recommend checking some of that stuff out. He's got all these different patterns, or the Saga pattern and all this kind of stuff on how to address this. And of course, the deployment can be challenging and increased memory consumption. So it's not all without its challenges. So what role does the API gateway play in this post-monolithic world, right? Well, monolithic applications, everything lived happily together. They're all tightly coupled, and there was a single point of entry. You authenticated, and then there was this, space that the trusted space where all the functions lived together, and it worked that way. And then, as I mentioned, there would be resource impact from other functions, and then you didn't need additional authentication in the downstream calls. Like once you authenticated, then you continue to do that. I mean, there are cases where like Java supports further security within the monolith, but I don't know a lot of people that used it. It was difficult to leverage, and then authorization was at the entry. You could do that at the functional level. With microservices, each microservice represents a function. So here, there's no longer this wall or single point of entry, right? So technically, you could just call any of those microservices. So you have to really think about how you architect it. And there's no resource impact from others, and each downstream call needs to be authenticated as well, right? Remember, like in the monolith, if you have function one call function two, well, they just called each other. It's all tightly coupled in the way they go about doing their business. But over here, well, if they're living in containers, if function one wants to call function two, you have to have some sort of authentication. You don't want to just make a REST API available to whoever wants to call that. So you got to think about how that looks like, and then you got to also do authorization at each microservice. And we're going to talk about what the different options are. So here's just a quick diagram that shows, there's a bunch of services, there's a couple microservices, and the data model and the different consumers. You got a mobile client, desktop, and an external service that's calling that. So here's a bouncer could be at a club, it could be at an event. But what do these people do usually, right? They've got a guest list, and your name may or may not be on there. But before they check that out, the first thing they do is they authenticate you, right? Like, hey, show me your ID. And they look at the picture, they look at you, they go, okay, well, you are Farshad. I've authenticated you. You are who you say you are. But the next thing I've got to do is see if you're on that guest list, and you may or may not be there. So you authenticate and then you authorize. And so with API Gateway, you could act as a single point of entry where you essentially enforce security policies like authentication or authorization. So that API Gateway becomes this guy. And imagine if you're going to a conference, right? You got to go through the front entry, but once you enter the big conference, I mean, this is a single track conference, but imagine you're going to RSA and there's multiple tracks and there's VIP rooms and areas where everybody can't go, right? Well, when you go to RSA, you get your badge as a regular attendee, but then depending on which special section you want to go to, you might have to have a special color or something else that's special about your badge, and you go and show that and you get into that room. They don't authenticate you once you're inside at every one of those things. All they do is they just look at, hey, are you authorized? You have the right color in your badge, right? So similar thing with applications, what you got to do is have that initial authentication, and then once you go to the different microservices, then they can apply the authorization. And you can issue tokens once secured, and then that's if the security policies are met, right? So it's like when you go to the conference, if you have the tickets and you show your ID, then they issue the ticket or this token which you can then show at the different rooms and be provided access to those rooms. So that's what I call heavy authentication. So the heavy authentication, you go up and show your driver's license, show your ticket purchase number, and all that kind of stuff. It takes a couple of minutes, a few minutes, but then you get the badge, and then after that is really quick, right? So if I want to go to the speaker room, all I have to do is just show this and I get it. This is like my auth access token for those of you who are familiar with OAuth per se. So there are also non-security benefits of API gateways. You can expose different APIs for each type of client, like mobile versus web. You can route requests to different microservices. You can create mashups using multiple microservices, right? Like things like MuleSoft, they support these models where you can combine different layers of APIs and create mashups. You can abstract service instances of their location. You can hide partitioning. You can provide protocol translation, right? In heterogeneous environments, you might be using different, you might be mixing REST with SOAP, and that you can do that kind of thing. So, why is user-level security context important, and what is end-to-end trust, right? I often see companies, what they do in the old days, right? You had a monolith, they connected to the database, and you use the connection string or username and password, and it was fairly straightforward. And a lot of people had authentication between the different components. As we're going through these modern architectures, people are like, well, yeah, I have this access token, I pass it around across my different components, and it's like, well, okay, that's good. But what if someone actually was able to intercept and grab that token? Now anyone can send that token to any of your services. So how are you establishing service level trust, right? So it's important to really think of this holistically and not just say, well, I'm taking care of one authentication here, I'm passing the access token so the user context carries through. But what about service level? Or vice versa, you might be doing only service level authentication between your services, but then there's no user context. So you gotta take care of both of them. User level context is really key. And in traditional systems, user-level security was not carried across the components, right? So here, you would authenticate, and then the monolith knew who you were, but when a monolith talked to the database, everyone looks the same. There's no user context, right? The data layer just simply processed the request for everybody. So you need to take user-level context into account. You need to use tokens to determine user security before servicing the request, right? So you have claims in your access tokens, and you look at the claims, and you service the request based on the claims and based on your authorization model. And you gotta maintain that user level end-to-end trust across all the downstream calls, right? If your architecture is really simple, where you go from the client into the API gateway, into the microservice, and that's where it ends, well, fine. But there are, like where I worked, we had really complex user journeys, flows, where there'd be multiple microservices called downstream. So then you gotta really think about that, because if they all require the same authorization level, well then a single access token will work. But if they don't, then you need to exchange the access tokens for ones that give you the right scope and the right permissions in the downstream call. So that's something that you should architecturally consider. So we talked about this already, so I'm not gonna spend too much on it, but it's really important to do both of these. So make sure that all your microservices and the entire journey understand who the user is and what they should have access to, and then act accordingly, but also make sure that you got that service level trust, just in case someone's token got stolen, that it doesn't come from a rogue agent, right? That the token should be coming from the service that's actually allowed to be sending that token to the other service. So that's really important. So there's two different options. As I mentioned, you can do the token exchange endpoint. So if you've got, this is particularly handy for heterogeneous environments where one microservices API might be RESTful, the other one might be SOAP or XML. So what you do is when the service one, microservice one receives the request and processes it, if there's a downstream call to be had, it can go to the token exchange endpoint and say, hey, I need to call this service downstream. Give me a token that's appropriate for that service and appropriate for the user that I'm processing the request for. User level end-to-end trust is established among microservices of the same application, and so you can either, but what about microservices that are in another trust zone? So at the bank, we had these different lines of businesses, right? Like we had our retail banking, and then we had our, say, commercial banking, and they wanted to be able to have these users that have authenticated into one, be able to essentially kind of do single sign-on and access microservices in another application. So you should probably go through the API gateway for that microservice. So if this is application one's microservices and you've got a token for that, this token may not be appropriate to access the microservices for application two. So it's probably a good idea to route it back through the API gateway and then look at the context of what this user is trying to do and issue a new token. And I'm not promoting any vendors, but Apogee does a pretty good job at this. They create these application groups, right? So you can take certain microservices that belong to an application and then group them, and then it'll apply the policy consistently to those microservices for application A versus application B, which is quite nice, the way they do that. What about authorization? Well, we've been talking about authentication and all that stuff, but authorization is equally important. So each microservice may have specific authorization requirements, right? Like one microservice may only let the user read something, the other one may let the user read and write something. So security token service can issue a token based on the resource that's been requested, the scope or type of it, or the user's current authentication context, right? You might have microservices that require higher level, they might require multi-factor, whereas a microservice might require different security context. So you can issue a token based on all of those, and the token claims can include the user's identity or the issuer's identity of specific consumers, expiration time, and all of that kind of stuff. So in this model, each microservice would verify the authenticity of the token first, right? You want to make sure that the token you've received is signed and it's not been tampered with and it's actually coming from an authority, signing authority that you trust. And access is provided based on the valid authorized claims, right? So you look at, hey, this one says that in the claims that it's Farshad and it's his ID, but okay, just like that bouncer at that event, right? Okay, now you know it's Farshad, but is he on the authorization list? And either you can have that authorization list or policy information, as the OASIS organization who created the ZACML standard talks about. You can either have the policy information within the microservice. It might be a bit difficult to manage, or you can have a central policy information point where you can have that stuff be handled by the token exchange endpoint. So you can just have the microservices send the request off to that token exchange endpoint where it has all the policy information and make that decision. It really depends on what you're trying to build. Either there's no right or wrong way of doing it. It's really contextual. So with option one, the token exchange service gets a new token for the downstream calls. It's more flexible, there's better access control, but it could become a bit of a performance issue or a single point of failure. With option two, each microservice handles the authorization using a single end-to-end trust token. So you can just have one token that's got all the right claims that just gets passed around from one microservice to the next. But the downside of this one is that if you have microservices with different authorization requirements, a single token is not going to be that great for that. So what about all the protocols? I've talked about SAML. So SAML is used for both authentication and authorization. It's XML based, right? Now, OpenID came out a while ago. Now it's been replaced by OpenID Connect. So that came out to be used for authentication only. So this is one of my pet peeves. There's a lot of people out there that say, oh yeah, I'm using OAuth. And I'm like, okay, how are you authenticating? They're like, OAuth. I'm like, well, OAuth is not an authentication protocol, right? Make no mistake, OAuth is an authorization-only protocol. So OAuth came out, and then it only handled authorization, but it didn't do authentication. So then they had OpenID Connect, and the two weren't really connected, right? Like OpenID Connect was like, hey, sign in with Google, sign in with this, sign in with that. It was great. Like you could connect your WordPress blog and have your users sign in with Google. That OpenID handled that. But then they're like, well, why don't we bring the two together, right? You kind of need authentication and authorization. SAML did both of them. So OpenID Connect is essentially a bunch of extensions on top of OAuth that provide the authentication, right? So if anyone ever tells you they're using OAuth for authentication, run away, because they probably don't know what they're talking about, and it's not so good. And that's, I see a lot of people, a lot of developers that I work with that make that mistake, and that usually smells that there could be other security problems. Because if you don't really understand what OAuth is, and you're telling me that it's for authentication, that means you probably don't understand security very well, and that's going to lead to other problems in your software. So I usually use that as a point to dig in further, and that's quite important for all of us to note. And then what these things do is that with OpenID Connect, you use it for authentication authorization, an extension of OAuth 2, as I mentioned, but it uses JSON instead of XML, so it's a lot lighter, and it's really designed to be friendly for external web applications. And it supports ID and access tokens as well. And what's really funny, I know one of the guys that contributed, Dick Hart, to the OAuth project. He's also from Vancouver. And there was a bunch of people that wrote the OAuth spec, and one of them just quit, because he wrote a blog post, which has now since, it's been taken down. I tried to find it, and it's not on the internet anymore, but he wrote this blog post. He's like, why I quit OAuth? Because it's not because it's not secure, but because it's so complicated to understand that people can make mistakes. And everything is just not built in. You really need to know what you're doing to secure it. And that was his whole point. And it is true, I 100% agree. I mean, I've been dealing with this stuff for 10 years, and even I sometimes get confused, and let alone all the poor developers that I work with, and you can't expect them to understand this stuff really easily. Companies like Cognito or Okta, whatever, they try to make it easy, but even I was reading Okta's documentation on some of this stuff, there was lots of errors, and I'm comparing it with the RFC. I'm like, hey, you guys are a company that works in this space, but even the examples you provided here are actually incorrect. So again, not anyone's fault. It's not a very easy standard to understand. Okay, so what about invocation by external applications? So we've talked about all this stuff so far. Microservices may be invoked by others outside of the trust boundary, right? You might have another headless service that wants to call it. So you have to establish trust between the two identity domains of that application and this one so that they can, talk to each other. API Gateway can issue a new security trust token for the external caller if you set it up that way, but the security policies might be different, similar to how you would handle users accessing different applications with different identity providers. But without central handling, each of these would need a trust relationship with external consumers, and that is really challenging to implement. Okay, the moment you've been waiting for, let's get off of authorization and authentication. What about other security issues that you should care about, right? Like authentication, authorization is not everything. You should also think about rate limiting, right? You're going to be exposing these APIs externally, hopefully through an API gateway, but attackers are going to hit you up. They might have a botnet. So how do you handle rate limiting, right? And there's all kinds of sort of rate denial of service type attacks. It could be volumetric. It could be at the application layer 7. In here we're talking about application security. So an API, a lot of these API gateways, MuleSoft, Apigee, and Zool, and all the other ones, they have functionality that help you with rate limiting, or even the Amazon API gateway or the Microsoft APIN. You can also do JSON threat protection. They usually come with out-of-the-box policies that handle this type of stuff, or XML threat protection, or you can even write your own custom policies, right? So at the bank, I worked with the platform engineering team, and what we did is we're like, hey, you know what? We don't want the developers to learn all this stuff. Why don't we just make a bunch of policies out of the box? So we came up about 6 different patterns for different applications, and we said, hey, we make this available to the developers. So if you're building this type of application, here's the pattern for you. Deploy these policies, and then you don't have to worry about all these things anymore. You just focus on building the microservice and focus on building the logic and the business functionality, and then the security will be taken care of by the policies that we've created, right? So then they can focus on what they're good at. The security team, we really focused on making these policies flexible and making them do what they're supposed to do, and then that's great. They would just deploy it into our platform, and then the right policies would get applied. I mean, that doesn't mean that there aren't other security things that the developers shouldn't focus on, but at least it helped them quite a bit so that some of the stuff didn't have to be dealt with by the developers. And so yeah, you can make these pre-built policies, and actually OWASP's ASES, there's a control that they recommend that and say, hey, where possible, use centrally enforced security controls, right? Like try to do that, try to reuse, and rather than everyone is building their own security control into their own microservice, which is going to be chaos, try to centralize it, make it available to the developers, because it eases the development process, and it avoids the learning curve, right? It avoids like, hey, why should they learn about all this stuff? They should. You should do a presentation for them. I'm not saying that. But it makes it a lot easier if you've already included these security policies in your API gateway for them. And you should also apply group policy, right? Like those of you who've been in the IT business, they know, like you don't apply things to the user, right? Like in the Windows world, for example, you always do things based on group. Why? Because if you apply custom permissions to users and you need to go change something, it's going to be difficult to manage, right? You always do things on a group level. So here it goes the same thing. Apply group policy. Figure out which of these microservices belong to the same application, group them, and apply that policy consistently to that group. As I mentioned, products like Apigee make that easy for you to do. And so it helps you in consistent application policies. It groups APIs that address a particular business need. And we provide that group to the developers and say, here's a service plan with a set of policies, just build into it, right? It makes everyone's life quite easier. And then security token should only be valid for APIs in that group, right? You shouldn't just make these widely scoped tokens, which I see quite a bit when we do assessments for clients. You should try to narrow the scope. And so, for example, if you have an account servicing application that's internal, is XML based and uses Active Directory, the policy would be Active Directory based authentication authorization, XML threat protection, and rate limiting that's appropriate for an internal application, right? Whereas if this was a shopping site that was external and JSON based and uses an LDAP for an identity provider, then it'd be an LDAP based authentication authorization, JSON threat protection, or rate limiting that's appropriate for an external facing application. Log all the things, right? This is another problem that I see when we do assessments on client applications. Logging and monitoring is usually not thought about. We were talking about this as well when the speaker did it last night, is that logging and monitoring is often an afterthought, right? Who thinks of that? ASDS has controls for it, and I always tell the developers, hey, you gotta do at least, the key things is log authentication, authorization, success and failure, authorization failure, as well as deserialization failure and input validation failure, right? Because if someone is trying to do reconnaissance on your API, you're going to see a lot of failed authorization, right? That is something that you should be alerting on. So at the minimum, those are the 4 that ASVS recommends, and I highly encourage everyone to be at least doing that, because detective controls are important. The longer you let the attacker do their reconnaissance, the more likely they are to succeed. So if you catch them early, particularly if you've done the 4 things that I mentioned, and you correlate them properly and raise the alerts, then you'll really reduce the chances of them being successful, right? But again, this is, at the bank even, I would ask people, the development teams, hey, what are you doing for logging? They're like, well, we're logging things. What are you logging? Well, we're logging the actions that the user performs. Where does it go? Well, on the local machine. What about after that? Doesn't go anywhere, right? And okay, so what happens? Oh, well, the logs are on that machine, they get rotated and they're gone. So that is not really helpful. You need to have the full end-to-end story where the logs go into a central SIM, they get correlated with all the other stuff that's happening, and then you get the full picture, and then you can figure out if you're being attacked, and then hopefully you don't get breached. So API should log important things, as I mentioned, and API logs can help with fraud prevention as well. So, takeaway, I'm not going to give you some Chinese food in a box, but I'll give you takeaway considerations. So use an API gateway, right? I can't say that loud enough. If you're building microservices, it's really important to be doing that. Don't just expose the microservices on their own and hope for the best. Make sure you're doing that, and make sure you're centrally enforcing policies, and they're appropriate for what you're building. And the other thing that I want to say really loud and clear, do maintain end-to-end trust across the journey, right? Not just parts of the journey, and then on top of it, make sure there's service level authentication. All your services should either be in a service mesh, right? Sort of Istio, great product. Again, don't work with them, but you should create a service mesh or some sort of a boundary so that these microservices can only talk to the ones that they're supposed to talk, that compose that particular workload, right? If they're not part of that workload, why are they allowed to talk to each other, right? Because if you just say, well, I have an access token, but like I mentioned earlier, that access token can be captured and compromised, and then a rogue agent could be sending that access token to one of your microservices, and you don't want that. You want to make sure that only the authorized components of that workload can do so. And enforce authorization at the right place and the right level, right? At your API gateway, maybe you don't have enough information about the granular functions of the application. You could do macro authorization. Hey, are you allowed to access this application at all or not, right? And then further down at the microservice level, you can do your micro authorization or micro entitlement, where because that function knows about the specific things that the user should or shouldn't have access to, and that's where you can do that. And then group them to apply configurable policies consistently, and don't forget to log, monitor, and detect. That's really important. And of course, any security person will tell you, follow a defense in depth strategy, right? Make sure you got the right controls at different layers. And finally, build security into the service architecture and use security by design. I can't stress that enough as well. So that brings me to the end of this presentation, and I'd like to open it up for Q&A, and I hope you enjoyed this discussion. I left HSBC 2017, and I still keep on top of that industry. There isn't a regulation that's specifically enforced. There are things like FIPS and PCI and all that, but like PCI is really, I remember when PCI came out in the late 90s, early 2000s, it's still very network focused, very abstract. As Adam was saying, when it comes to application security, there aren't any specific guidances or regulations. So what I was hoping for, in Canada, they did something good for a brief moment. For about 3 years, the Canadian government put out this baseline cybersecurity advisory for companies, and they actually said you have to do ASVS, and ASVS requires a bunch of these things. But then they took it out, because they're like, well, US isn't doing it, why are we enforcing that? So they actually downgraded the requirements. But hopefully things will change for the better as liability and some of these things kick in. And say, hey, if you're building an application that's handling sensitive data or the risk level is high, you must do X, Y, Z, right? And that's what ASVS is designed to do. They have 3 different levels of assurance. They're saying if your application requires level 3 of assurance, then you got to do all kinds of things like architecture and design and everything else. But if it's level 1, the architecture, design, and controls are not mandatory. The Application Security Verification Standard. It's a wonderful OWASP standard. It's one of the ones that I live by. Pretty much our company is based on SVS. Next question. Thank you.
web application firewalls. What are your thoughts on them? Because I work with some of them and with some devs, and there seems to be like kind of maybe a mismatch of like, hey, you can't just deploy and go. There's got to be some sort of tuning. How do you kind of walk that line?
Great question. As a software security person, there's an interesting relationship with WAFs, right? We say as a rule of thumb, it's better to harden your application rather than rely on something external, right? So my first recommendation was build your app security. But that doesn't mean the WAF is completely useless. As I mentioned, you should do a defense in depth or follow the layered security approach. What WAF is good for is sort of like an IDS for layer 7, right? It's looking at traffic and says, hey, I saw this pattern, I saw this SQL injection payload or this thing that could result in something bad happening to your application. So if you haven't hardened your application, I'd say go and put a WAF in front of it right now because it helps, right? But just like an IDS, it doesn't really have visibility. I mean, a network-based IDS, I should clarify, doesn't really see it doesn't have inside visibility. So it doesn't really see if that SQL injection becomes real, it gets realized or not. It just sees that it's going to your application. Your application might be using an ORM and SQL injection is not a problem. WAF doesn't really know that, right? You can fine-tune it, but in general, it's just sort of it's a good secondary protection to put it in between so you get more observability and you can stop some of those attacks if your application is not hardened. So that's what if I go to a client and they're like, we haven't done any hardening in our application, put a WAF in front of it right now while you work on actually strengthening the application itself. Now, it's a bit of an interesting thing. Like 10 years ago, we would have WAF is a separate thing out here, the application's over there. But right now, one of our clients, they're building this system that's all microservices, and they challenged me on it. They said, well, look, Farshad, wouldn't that just be another microservice? Like, I've got all these services, isn't that part of my application? Why should I harden my application, right? Because this isn't an external thing. This is just one of the services. This is my security service. So I'm like, that's actually an interesting argument, but it still means, like, I would still say that go and secure the microservices too, even in that case, right? So which is what we did with that client. Thank you.
Yes, so with microservices, there are poly repos. With every microservice, you have a repo, and even if you have developed it secure by design, over time it gets stale, and there is some amount of housekeeping that needs to happen. So I know you touched a little bit about maintenance, but that adds a lot of tech debt. So do you have any comments in terms of how do we drive that maintenance as AppSec and as an AppSec team?
It depends. That's a good question. I'm trying to think how to answer that because it really depends on how you've designed things, right? Can you give me an example? Actually, that might be really helpful.
Yeah. So if you have you're building a platform and you have probably hundreds of microservices, right? So once you ship a microservice out, you're probably not touching it unless you're getting a business requirement.
Right.
That's from the development team's perspective. But we are consistently monitoring and scanning all the code, and we probably find out, okay, there's a new software composition analysis detected a new stale component, for example. Or at the time we did not, our scan engines were not strong enough, so maybe we did not detect some misconfigurations or whatever. So there is some consistent housekeeping that needs to happen. So obviously from agility perspective, shipping out is fast and secure, but how do we make sure that they remain secure?
Gotcha, thank you for that example. So as I mentioned, there are some maintenance challenges. So in that case, it isn't all that bad, right? Because let's take your vulnerable package, right? Sure, then you have 100 microservices, that vulnerable package may be in 80 of them because that's where you're using it, you have to go and update them. But the advantage of, remember what I was talking about centralizing security? So in this case, a lot of that stuff, like the security things that you would have previously built into the monolith would probably be implemented centrally in your API gateway. So in certain cases, it might just be a matter of just adjusting the policy at the API gateway rather than touching all 100 microservices. So it's sort of some of it will be things you'd have to do across all, but a whole bunch of it would be things that you could just do centrally, and that is one of the pluses of going in that direction. Yes?
When you're talking about XML and JSON protections, are you talking about stuff like preventing XML external entities, malform JSON, or something else that I'm missing besides just like the data format itself?
Yeah, like the threat protection policies for XML in particular, they would look at the payloads that are going through it. If they see, hey, the attackers put an XML attack with like data type definitions or something that's in the payload, they're like, hey, this looks malicious. This person's trying to access a resource outside of our environment and go, hey, we should flag this. But again, because if you're looking at this at the API gateway, it's similar to the WAF, right? It's not going to see whether that gets executed or not. So the policies that you enforce at the API gateway are kind of like the WAF analogy because it's disconnected from the application. It might say, hey, I found this XML threat, but would it have gotten realized? Well, you're not inside the application, so it's sort of that situation. Awesome.
With the recent rise of microservices, would you say AppSec in general is harder? And if so, is there any hope?
I would say it makes it easier, right? Because like number one, the developers don't have to, if you've centralized all your security, made the policies and put them in your platform, and you have a single point of enforcement through your API gateway, there's less for the developer to do. They don't have to think of all the, not all of them, but some of the common security things that they would have to think about, right? But it's a bit of a different paradigm for them to wrap their head around. So I think overall, my thought that would be it makes it easier for the developers, minus some of the management of the tech debt or dealing with the distributed model. But that's sort of the idea, is that it's supposed to make life easier by centralizing some of that stuff.
I have like a couple of questions. So the first thing, right? So we have like hundreds of endpoints and like thousands of servers behind, but like with this kind of API gateway, does it become like kind of a single point of failure when there is some kind of a DDoS attack or something? Or like how can we scale, or like are there strategies for separating out critical APIs and non-critical APIs?
That's a really good question as well. If you're deploying that API gateway yourself, like let's say you went and got Zool, which is great, and then you just put in a VM and run it yourself, then you'll run into that single point of failure and the scalability challenges. But if you go to Azure, you use APIM, Microsoft scales that for you, so you don't have to deal with any of that, right? So if you're in the cloud, if you're in AWS API gateway, you can set it so that it scales, deals with it, it's not going to be a single point of failure. But if you're going to be deploying in the VM, yes, that could be a problem. So it really depends on the size of the organization, how you're architecting it. For small companies, I mean, we're a small company, we've built an application that's using APIM. APIM can get expensive depending on the deployment model. They have, like the general one that you use, it runs in a common environment with everybody else's stuff. If you want your APIM to be a dedicated instance that only you're using, it gets really expensive. So at first, we started building it that way because we wanted the ultimate security, and then we realized, hey, that's quite costly. There are workarounds, like what we did is we took the regular APIM and then we used an Azure function to be able to link it to a VPC and have a private endpoint and not have the traffic go through. And I'm happy to talk about those things offline if you're interested. Yeah.
So for UI, like in case of DDoS, like or like kind of a brute forcing, we have like multiple approaches, like kind of a CAPTCHA, or like we have multiple approaches. But for APIs, it becomes really harder in case of like live attacks. So how do we handle those kind of things? Because like rate limiting has its own problems. Like if we rate limit on endpoints or like based on IPs, so like the actual customer would be like really impacted. So do you have any thoughts on it?
Yeah, if you do it purely based on IP, there could be impact because some customers need to send it at a rapid rate. Some of the stuff now bubbles up above the API layer, right? Some of these things you still would have to continue to deal with at the application layer, present the CAPTCHA and things like that. There are application rate limiting solutions, like I know some frameworks provide that, so that it's not just based on IP, it's based on, hey, this particular user account, someone has been trying to brute force this particular account, and then they'll block it based on that. So at the account level or different ways, but yeah, at the end of the day, some application level protection is required when you're handling those kinds of issues. Any other questions? Yes.
The need for security at HSBC is very clear. I work at Now Secure, and so we test applications for companies that obviously have that same need. But I think many in this room might know the challenge of explaining the importance of security to non-IT professionals or people in the business sector. So I'm wondering how you advise smaller companies that maybe simply have a website or an application. How do you advise them on security, on looking at security or implementing security protocols when their focus is more on building their business?
I can speak that from a personal experience because I'm building a business. We're a 14-person company. We have software, and I'm like, well, what do I do here? Because you've got all the security stuff you've got to do, and then you're also a small company, right? So one thing I learned though at the bank was risk-based project management. Like at the bank, everything was risk-based. You're going to drink water, what is the risk of it? You're going to do this, what's the risk of it, right? So that's what I usually recommend is do a quick risk assessment. What is the risk of this? If it's low risk, then at the bank, if something was high risk, we would have to fix it now. If it was medium risk, you would get a dispensation, 6 months to 12 months, and if it was low risk, do it whenever after that, right? And that's the approach that I take, and that's what I recommend, is do that risk assessment. Doesn't matter what size of company you are. If the risk for you is high, you gotta deal with that, right? But if it's low and you're a small company, put it in your 1 year roadmap, after you fix all the other things. So that's one thing I learned that was really valuable, is acting on risk. And yeah, I hope that answers your question.
So following up on that, what is the risk of attackers pivoting around your microservices? Are there like case studies that show that, hey, this is actually a part of their attack vector now, or part of their playbook?
That is a really good question as well. Like, do you need Istio? Like, what is all this stuff? You know, what good is it for, right? It gets into like the asset, like how much is at risk, right? Like at the bank, we had a lot of risk. If one of those applications gets breached, some of the largest companies, including Microsoft, would not be happy at us. But if you're a smaller company, then you're like, well, okay, I'm hosting these microservices at Amazon. I recognize that this is public cloud. Amazon says, by the way, you should implement TLS like everywhere, like even internally. But then it's like, how would someone get in within your VPC? Because imagine if you have all your microservices there, could someone stand up a rogue agent in there? And then once they did that, could they be talking to my microservices? Now here's the thing, with smaller companies, usually it's like, oh yeah, everyone has access to that production environment. So that's that. If you could get your small company so that you can not have everyone access your production environment, now you've reduced the risk, because you're like, well, it's difficult for someone to stand up a rogue agent in that environment because no one has access to it, including, except for this one person who's in charge of rolling out, or this pipeline that rolls out to production. And that pipeline, in order to do that, requires a whole bunch of authentication authorization. But if you're working in a small company, which I see a lot, where everyone has access to that environment, then it's pretty likely that either a developer could get compromised and then they could leverage that account to stand up rogue agents, or one of the developers may be malicious. But again, if you're a small company, there's a lower likelihood of that, right? Because let's say 10% of people are malicious, then you only have 10 people. Less likely, but if you're a 100,000 person company, then higher chance that you could have malicious inside it. So again, I would take a risk-based approach into that one as well. How are we doing for time, David?
You take one more question.
One more question.
Hey Farshad, Quiz here, OWASP Portland. I just want to first thank Farshad and Jeevan. I think it was 3 years ago, you reached out to us here in Portland and said, let's do a conference, let's talk about it. So the reason why we're here, the reason we've had the last 2 ones is because of Farshad and Jeevan reaching out. So thank you. And the question is, you're a OWASP chapter up in Vancouver. You have lots of great talks, lots of great things going on. I'm curious, for those of us responsible for OWASP programming in other chapters, what are some of the most successful, impactful talks or trainings that you've done around API security, specifically like workshops? Maybe
Right,
I'm going to pivot to Dana.
Do you want to speak to that one? You did a great, Dana did an excellent workshop on API security.
So we have to stop thinking AppSec first. We have to start thinking about the developer and the tester in the room, and start communicating and demonstrating to them the value. Because it can naturally turn them into security champions, which will get them into an AppSec path. The other side is that, I don't know what the magical number is, but if you were to think of how many security engineers compared to a developer in an organization, it's very small, right? So many of us are AppSec engineers here, security engineers. I'm an offensive security engineer, so I have a lot of fun at OWASP because I'm always thinking about how do I tear it down, right? And then how do I educate developers on this is how I would do things. So when people are talking about bouncing off of microservices, I love that because I try to get a foothold internally. They think their WAF's going to protect them. They have one STS, and I just say I'll bypass all of that and I have access to all of those microservices because you weren't playing nice and properly locking it down at the microservice level. So the concept of how do you educate and continue, one of OWASP's main missions is to make less insecure software, right? We want to eliminate that. So it can't be about the AppSec professional only. It has to be about the developer and helping them to become the security champions to eventually get into an AppSec role and move into that and do that. So what do we educate on? Anything that would relate to what are the pains that I have, right? Someone mentioned documentation as an example. It's always out of date. Well, that's not actually true if you actually do document-focused code development, right? It's very easy to generate your Swagger with proper metadata if you actually use the metadata when you're writing your APIs. Not a lot of people know how to do that. So educating them. By the way, there's a huge OWASP project all about that. over 288 projects that have all these different things to help developers get more security focused. So that's what I think OWASP chapters need to do more of. And we're going to continue, we've been talking about this, we're going to get a speaker bureau down in the Pacific Northwest so that, I'll come down and show like how to reverse engineer an API that doesn't have documentation, right?
Data security workshops are awesome. You have to attend them if you get a chance.
So we'll see them, but that's the thing to do. And we'll continue to do that and move that forward and make sure that there's more education to that. Because if you empower the developers as everyone's shifting left and they're supposed to be the ones now responsible for security and they're scared because they don't know anything about it, they don't know what they don't know, which is what things like ASVS guidance can help with, which we'll talk about later today. So that's the way I would suggest talking about that. I hope that helps. Kind of. Yes, definitely. That's part of it. Plus, it's the workshops and it's the hands-on and it's events like this, right? So, Farshad, thank you so much. Everyone, another round of applause.